Glad to have you here. Welcome to the University of Illinois and welcome to our newly constructed home, Adapta House. Some introductions. My name is Max.
I'm Rose.
I'm Mayur.
And I'm Key.
And before we give you a walkthrough of our home, we're going to quickly go through some of our design technologies. And if you have any questions, please don't hesitate to enter them in the chat and we'll get through them all.
All right. So, what problem are we solving? We are solving the affordable housing problem, which is a major problem all over the world. In United States, around 1 in 3 households spend more than 30% of their income on housing, according to the Joint Center of Housing Studies. Through this house, we want to address the housing needs of the whole community as well as provide a solution which can be accommodated in a global scale as well. As you can see on the right, due to pandemic, the housing crisis is going worse and worse because of the increased medical expense, unemployment. That has intensified the housing crisis, and we are providing a solution for that. So in Champaign, Urbana, there is a population around 226,000, out of which number of housing units are 102,000. Majority of the housing units comprise of single units, which is around 59%, and only 54% of the houses are owner-owned. In our community, the median age is 31 years, and it's mostly students and young professionals, and we are focusing our solution on those age range. So three core concepts of this house is flexible, affordable, and sustainable. Flexibility is achieved through multifunctional spaces, multiple ways to control HVAC, water, electricity of the house through our app and interfaces. And also, one cool fact about this house, the house grows and shrinks as per your needs. So sustainability was one of the core aspects we kept in mind. So all our walls, roof floors are high performance thermal envelope. Even the device selection, system selection was energy efficient was our first priority, which led to sustainable lifestyle among our end user. As you can see in the image, one can start with a small module of 600 square feet and then they can add more modules as the need grows. Lastly, we not only reduce the spatial needs, which led to reduce embodied carbon energy, but also operational carbon energy.
Some structural engineering components include our wood framing, which is lightweight and has a high tensile strength, and also natural electrical and heat resistance. Our prefabricated components, which ease construction and also allow a more consistent and reduced cost. And finally, an independent canopy, which results in a tighter sealed envelope and mitigates thermal bridging issues. Our home can withstand a snow load of 30 pounds per square foot, which is 10 higher than the Urbana average, and a maximum wind load of 115 miles an hour. And our construction management team likes to show off their modular housing design, which helps make our home more expandable, cheaper, more precise in its dimensions, has a low weather impact, and also is predictable in its schedule and cost. Our estimated cost using RS means is just over $295,000. And on the right are two construction progress photos where our students, if they completed an OSHA 10 construction safety course, could come on site to take pictures and do some on-site activities.
Now, looking at the appliances, we mainly are looking at the HVAC component right now to ensure comfort and good environment on the Adapt house. We first want to achieve two goals: to ensure the comfort of residents while remaining energy efficient, as well as being durable to resist extreme weather conditions and respond quickly to the residents' temperature set point. To achieve goal one, we want to integrate Mitsubishi and as well as surf ventilator with Mitsubishi HVAC mini split system to provide mainly the heating and cooling load, and surf ventilator to provide energy recovery system. To achieve goal two, we also integrate hyperheating inverter technology to ensure we have 100% capacity even at extreme cold weather conditions. Now looking at the appliances, all our appliances are Energy Star and ADA compliant appliances with Amazon Alexa and smart home integration. And our lighting would be 100% LED provided by WAC. And we also monitor our energy consumption and PV generation by using Sense Energy Monitor. And it basically tracks the generation of solar panels and also monitors the energy consumption to better optimize our annual energy load of Adapt house.
Our water team had 3 design priorities when designing our system. These included efficiency, resilience, and conservation. Our outdoor landscape irrigation consists of rainwater collection and a proposed gray water to landscape system. Our indoor plumbing is composed of PEX piping, electric tankless water heater, and low flow fixtures, all monitored and managed through Streamlabs home water control ultrasonic technology. Ultimately, this is a 29% reduction in water consumption compared to the EPA baseline. Moving on to our photovoltaics and electrical team, our PV system is a 7.68 kilowatt system comprised of 24 320 emission solar panels. The first array is connected to a grid-tied solar edge inverter. Meanwhile, the second array of 12 modules is connected to an Outback Skybox hybrid inverter. This is connected to a 10.6 kilowatt big battery, which is able to support critical loads for 2 days. This project would not have been possible without the incredible support from our sponsors. Thank you so much.
So there's an introduction on our design components. And now, without any further ado, we'd like to give you a tour of our home.
All right, so welcome to Adapt House. As we mentioned briefly before, we have flexibility, affordability, and sustainability in our design. And the way we use these spaces is this living room can be converted into a bedroom within a minute, and the furniture is used hydraulics. It doesn't take much effort to convert those spaces. As you can see, the pegboard there, multiple different ways based on the user needs. One can customize the arrangement and store different areas. Lastly, flexible control of HVAC, water, energy consumption is done through interfaces. And I would like to show how we can control and get inside about HVAC system using Alexa.
Alexa, what is the CO2 level?
Surf carbon dioxide is 644.
That's amazing. So not only the user needs were kept in mind, but also the house design incorporates mental health and well-being. So through Serve, we can regularly monitor what's the CO2 level in this house. How can we improve that level so that the house well-being is achieved? Also, as you can see around, there are ample of natural windows which has good lighting experience, which encourages productive behavior in this house. Lastly, as you can see around, we are using LED lights, we are energy efficient appliances, and also few of the ways we are making the house resilient is through interfaces and sensor integration. So now we would like to show how one can remotely control the water consumption in the house.
All right, closing the valve right now.
Isn't that great? It's all done through a touch from your phone. Next, this is the first time we are monitoring the structural health using smart plane. We have this sensor placed beneath the structure which monitors the humidity and temperature of wood inside this house. Also, one way the house is resilient is it can operate for 48 hours just from our key components connected to our storage. Hence, one can fully use this house with the use of those components. Lastly, in this mechanical room, we have a serve system developed by University of Illinois professor. We have this crawl space where additional provision of gray water has been considered in the design. And this smart electrical water meter, which has PEX piping, which makes it more flexible and affordable. For the future needs, the whole house is ADA accessible. As you can see, that has been done, incorporated in the design itself. All right. So let's say you have this one module and you want to expand. We have designed this module which has more needs and additional customer requirements in mind. So if you have a Q&A, we'll like to address it right now.
So could you comment a little further on sustainability of your materials? You mentioned wood framing. I don't know. I mean, it looked all pretty standard, but I don't know if there's some special aspects to that. Are those like local materials? You have sustainable harvest. What's your further details on that?
Sure, that's a great question. So the facade material, which is wood, has been locally manufactured and procured. The framing is all prefabricated, where we reduce the wastage material, and also the pegboard were designed and built by students in the house.
Uh-huh. So
And
you have prefab components that are brought to the site and assembled. So that is that part of the cost reduction?
Also, apart from cost, our main goal was to reduce embodied carbon energy. So, like as many local products we can use and recycle and reuse for other purposes, we had that in mind.
Good. And this area, your area, this would have peak loads in the winter. Is that right for the space heating? And what's your major energy consumption in this house?
It would be heating for the house.
In the wintertime heating. Yeah.
Yeah.
Yeah.